Cool. Yeah. So hi everyone. So I'm going to share something about the Spark, and hopefully you already know something about Spark. If not, I will try to explain some part of it. And feel free to interrupt anytime and ask questions.
So and I'll monitor the chat in case there are questions there.
Cool. Cool. Yeah. Just interrupt me anytime. So I would like to hear feedback, hear questions early, so we can discuss more. I want this two-directional discussion, so I can also learn from other folks. Yeah, not just me talking here.
Right on.
Cool. So this is my LinkedIn. So if you want to know me better, you can go there. Yeah, here will be the content. We have, I think, 1 hour. Hopefully we can finish early. Then we have more time to have Q&A and more discussion. So I really like to discuss with different people about different questions. Yeah. In the beginning, we will do some very quick introduction, and I will share some challenges running Spark. And to solve that, I built several versions of Spark as a service. I will share one of the versions. And also I will share some open source tool I personally built and open source it very recently to help to do this. Yeah. Cool. This is about myself. So I have been working in big data for a few years. And in Uber, I did a bunch of open source projects. So I did a profiler for Spark. So Spark is very distributed. So to profile all this CPU memory, so you need a good tool. Also for Spark, I open source remote shuffle service. It's helped to solve some scalability and dynamic allocation issue. And I open source DataPunch recently. It's a tool to deploy Spark on Kubernetes. I used to work in big companies like Uber, Apple, all this stuff. So now I'm just joining a startup called ZBlock. So we are doing some data infra for Web3. So basically, Web3 has a lot of on-chain data and people have a lot of off-chain data. So just make it easy to access those data. Cool. So yeah, I'm trying to quickly explain Spark. So many people may already know this. Just a quick recapture. So Spark, as people comment just now, is a very powerful tool and getting popular these days to process data. The biggest advantage, I would say, for Spark is ecosystem. It integrates with a lot of things. It's very easy to start and hook up with different pieces of data processing tools. And Kubernetes is a platform to run Docker containers. It's also getting more and more popular. So when two things getting popular, people are trying to combine them together. So people will run Spark on Kubernetes. It is the situation, so 1 + 1 is much larger than 2. You get a lot of benefits of these two sides. But it has some challenges. Not that easy to start. So, but after you solve all these challenges, it really works and it will work well. Before that, some people may ask, wow, why run Spark on Kubernetes? So traditionally, Spark is running on Hadoop environment, like a yarn, these things. So these days, there's Kubernetes. So why we want to run Spark on Kubernetes? Yeah, there's several reasons. If you search Kubernetes, the benefits from Google, yeah, you will see they list the 5 key advantages of Kubernetes. That's very, very right. And this is the industry trend. So industry is moving to more cloud native. So they move on Kubernetes on cloud. It's very easy to manage your infrastructure. And for Spark on Kubernetes, it can get you very low operation cost. If you run Spark on yarn, the traditional Hadoop stack, you have to have a operation team of people who know yarn very well to maintain all this environment. And normally it's a cluster with many machines. You need people to maintain them. If you're running on Kubernetes on cloud, each cloud provider has Kubernetes environment and manage them very well. So you don't need to operate all this cluster by yourself. So you get very low operation cost. And you get kind of unified compute platform. So normally you have a lot of services, they are run on Kubernetes. And now when you do data processing, you use Spark. If Spark also run Kubernetes, then everything is on Kubernetes. It's pretty simple and unified. You don't need to learn different stack. Yeah. Okay. Here's the challenge. There's a lot of challenges. So if you try to get Spark work on Kubernetes in the very beginning, I'm using AWS, for example. You need to do a lot of things. For example, you need to create an EKS cluster. You need to set an policy and a service account. Then you install some component to run Spark, like Spark operator. Then you need to learn kubectl and set up Autoscale. Of course, you need to add nodes, node group into the cluster. It's really a lot of work. For myself, when I start this, it took me days to get my first things running very smoothly. So it takes a lot of time. And yet, people try to solve this problem already. And that's the first thing people come out, the operator pattern. In Kubernetes, we have all kinds of operators. And the Google folks, they write Spark operator and open source. It's pretty good. So it creates an application CRD. It's called Spark Application CRD. A CRD is, for people who are not familiar with it, in Kubernetes, you can define your own structure of your new resource. So here, people just create a new resource called Spark Application. It has its own structure and a schema. So you can create Spark Application in a strong typed way. So it's way to reduce errors. The Spark operator can monitor the application status and try to restart the application for you if something is failing. And the chart shows basically how it works. So in the left part, you have some command line tool. You can apply a YAML to the Kubernetes environment. The Kubernetes then have the operator, it's a running process in the Kubernetes environment. It talks to API server to monitor new Spark application. So whenever there's a new Spark application submitted, it will read that application specification. So different fields, for example, how much CPU memory for each driver executor port, how many executor. It reads this information and it will really launch Spark in the cluster. Cool. So any questions? So am I going too fast or am I going too slow? Or so let me know. Yeah.
This all makes sense to me. It's a great time to ask questions or post them to the chat, folks.
Cool. Okay, thanks. Okay, so normally when you get your first application running for Spark, either you use Spark operator or you use Spark submit command. You want to check your Spark application when it is running. So Spark has something called Spark UI. It's embedded in Spark. In Yarn, it's easy to access Spark UI because Yarn has native kind of proxy to help you go into the server inside the Yarn to connect to the process there. But for Kubernetes, it's a little different. Kubernetes, by default, you cannot access to the process inside the Kubernetes environment. You have to do some tricks to expose the process to outside of Kubernetes users so they can access that. So this causes problem for Spark UI. Because Spark UI is running inside the Spark driver. And in Kubernetes, we call driver pod. Pod is like a process. It's a container. So in Kubernetes, well, it's tricky to access the driver pod to go to the Spark UI. There are different ways to solve it. Some people solve it through the ingress controller using some setup. Yeah, it works in some way, but you need to do a lot of setup. Also, it is possible to build a reverse proxy. So you can do all the HTTP requests and proxy that to the Spark driver. So I actually built a very small example service to do that reverse proxy. So both of these will work. But again, if you just start to run Spark, you probably find this is not working and you will spend a lot of time to dig into this.
We have a related question in the chat.
Okay.
So the question is, can one use Jupyter Notebook and connect to the Spark operator in Kubernetes to run interactive Python Spark code instead of a job?
Great question. Yeah. it is possible. Actually, we did that in my previous work, but there's a very caveat and to be very quick. So the very easiest way to get this work is you have a Jupyter environment, like a Jupyter Lab, something like that. It's in Kubernetes. Then you can run Spark in client mode. So your Jupyter notebook itself is kind of the Spark driver it is running. Then that driver can launch executor in the same Kubernetes cluster. That's the easiest way to start. But the client mode has some issue. For example, if your notebook use a lot of memory, the Spark driver may fail because out of memory. You can try to run in cluster mode in that case. For cluster mode, it's way more complicated. It needs a lot of development work. And you can try, but you need a very strong engineering team for that. But it's definitely doable. So to summarize, it is possible, and it could be done in client mode. It could be done in cluster mode, and the client mode is easy to start. Yeah. Okay. Yes, I think someone already answered. You have Spark client code installed in the notebook. Yeah, this is the client mode, something like that. Yeah. Cool. Okay, let me go back to the Spark UI. Yeah, you will hit that issue when you run in Jupyter Notebook, because you want to see your running internal task inside the Spark when you run in Jupyter Notebook. So you need some work similar like this to get it work. Yeah. Cool. Another challenge is logs. So your Spark application may fail. You need to access logs. The Kubernetes and the Yarn, they are different. In Yarn, it's very easy to access Spark log because Yarn itself has a log aggregator. It can copy your logs, put it somewhere, and again, Yarn will proxy your request to access those logs. For Kubernetes, there's no such thing. You have to deal with log by yourself. So normally in Kubernetes, people use some log shaping tool like FluentD, FluentBit, Logstash, all these things. They can collect your pod log and put it somewhere so you can search it. Yeah, you can do it. And another trick is in Kubernetes, when you run Spark, if your executor dies or your application finish, your executor will be gone. So you cannot go to your executor and figure out what's going on there. Then the Spark config, you can set to false. So that will help you to keep your executor pod when the application finishes. So you can go to that executor and check by yourself. Okay. Cool. So another very big topic is dynamic allocation. It's a very, very large topic. I'm thinking how to make it simplified. So in Yarn, Spark has a big feature called dynamic allocation, and people write a lot of code to support that. You have some background, some people may not have full knowledge about what is dynamic allocation. So dynamic allocation is when a Spark is running, the Spark has different stages or different phases. Some stage, it may just process very little amount of data. Some stage, it may process a lot of data. So the compute resource requirements are different in different stages. So without dynamic allocation, you have to allocate your compute resource to make it fit your worst case. For example, in your worst case, you need 10 machines to process 1 terabyte of data. Then you need to allocate 10 machines in the very beginning. That is without dynamic allocation. Well, it's wastes a lot of resources. It probably costs a lot of money. That's why the Spark community built a feature called dynamic allocation. So with that feature, you don't need to pre-allocate so many resources based on your worst case. You can just tell Spark to run. The Spark will dynamically acquire new resource, new compute resource when it find it needs to do that. For example, it may start just with one executor to do some job. Then it find, well, I have too much data, so it will add more executor to run your job. In this way, it's very efficient. You don't need to waste a lot of money. And it can increase the cluster utilization greatly, reduce your cost. Again, in Kubernetes, it's different from Yarn. In Kubernetes, the challenge is your data will be gone if you use dynamic allocation. Your one side effect of dynamic allocation is when Spark don't need so much resource, computer resource, it will kill executors. For example, it launched with 10 executors in certain time. Then it finds, well, most executors are idle, so Spark will kill maybe 9 of these executors and only keep 1 executor. So when that happens, your pre-existing data on those executors will be gone. More specifically, there will be a lot of shuffle data. So shuffle data is the data for different stages. Anyway, so all this data on the executor will be gone. So your Spark may hit the issue when it runs the next stage because some data is gone, it cannot continue. In Yarn, in Hadoop world, it was well solved because Yarn has something called external shuffle service, like external shuffle service I put here. Yeah, I won't dig into detail, you can search, but Yarn solved this with this external shuffle service. On Kubernetes, well, there's no such service, or it's very hard to set up such a service. So in the end, nobody set up this external shuffle service in Kubernetes for Spark. So it's very hard to use dynamic allocation. And fortunately, the community is aware of this and are building something to support this. So they try to, the community Spark, open source Spark, try to track the shuffle data. And when the Spark try to kill executor, they will check whether the executor has the shuffle data, then decide whether to kill that or not. And when I was in Uber, we solved this problem in another angle. So we built a Uber remote shuffle service. Basically, we decouple shuffle data from executor. So executor is still there running, but we relocate the shuffle data to another dedicated server. So when executor is running, the executor just writes shuffle data to that dedicated server. So Spark is free to kill any executor without worrying about losing data. So the data is still in the remote shuffle server. So it can solve this problem. Yeah, this is a big topic. I want to check whether there are any questions. So,
yeah, I guess 2 questions so far related to dynamic allocation. Using these settings, can you scale up Kubernetes or just the new Spark workers on Kubernetes?
Oh, yeah. Thanks for clarifying that. This, yeah, sometimes it's a little confusing. Dynamic allocation and Kubernetes scaling, they're different. For Kubernetes scaling, you can use Autoscale to add or remove machines in the Kubernetes cluster based on whether there are pending pods. Spark dynamic allocation is different from that. It's Spark itself to decide whether to add or remove executor by itself. So Spark allocation is only working in a single Spark application level. And the Kubernetes scaler work in the whole Kubernetes cluster level. They are different, but they are impacting each other in certain way. For example, if Spark find it need more executor, it may request Kubernetes to create more executor. But if Kubernetes do not have enough nodes, so Kubernetes will see there are a lot of pending pods. Then Kubernetes may trigger Autoscale by itself. This is how these 2 pieces connected, but they are different. So we'll design your environment yeah, always try to keep it clear the boundary of these two pieces and think how they can interact with each other in some good way. Yeah. Cool. So
And the other question is, if you will you discuss challenges you faced in cloud or cluster mode, so as opposed to client mode?
say it again.
Will you discuss specific challenges that you faced when you're running Spark in cluster mode on Kubernetes as opposed to client mode?
Oh, I see. Yeah, I mentioned it just now a little for the Jupyter notebook, but I won't specifically compare these two. So here the challenges, they normally they exist for both. For example, the application that exists for both client and cluster mode. And from my experience, cluster mode is a more scalable way and more reliable way where you get things working. So in big companies, in my previous companies, most of the time we use cluster mode. But for example, in certain time, like Jupyter notebook, to get a quick start, we use some client mode. But in other circumstances, we use cluster mode.
Awesome, thanks. Just a time check, we're about halfway through the hour.
Cool, great, thanks. Yeah. Okay, let me continue. Okay, this is another very interesting topic, also a big topic. Spark has something related to scheduler, and Kubernetes has a concept called scheduler. So by default, the Kubernetes scheduler is designed for online service. It's not really designed for Spark or other batch processing jobs. It may cause some issue. The major issue is there's no queuing mechanism. Again, if we go back to the yarn in Hadoop world, when you serve application, this application can be queued in different queues. So just they wait one by one, so they don't compete each other. In Kubernetes, it's not like that. There's no queue by default. So every Spark application, they will compete with each other. It may not work well in the end. The Spark community and the Kubernetes community, Apache community, they come out a lot of ideas and the solutions for this. I won't dive into each one. So if you are interested, you can look into this by yourself. So Volcano is from Apache. Oh, no, sorry. Volcano is not from Apache. It's from Huawei. They developed some scheduler to make this easier. Unicorn is from Apache. They are inspired by Yarn, so they build another scheduler for Spark on Kubernetes. And some other companies that doing some plugin inside the scheduler to mitigate this issue. So a lot of details I won't cover too much here, so you can search online to get a lot of information. It is not well solved. All these options, they are still actively going on. So it's a good time to jump into this project and track their progress. Oh, Autoscale. Yeah, we talked about this a little bit just now. For Kubernetes, it has Autoscale, so it can help you run your workload. Yeah. And because Spark and the Kubernetes, they are so flexible, you can configure different things in different way. There's no best way to do this kind of scaling things. I just share one example. This may not fit your scenario, but just give you some start and something you can take it and do some tweak by yourself. For example, sometimes in the same cluster, we use different node groups for different teams. You have big teams, and some team may use Spark a lot and use all the resources. So you want to isolate different teams. So sometimes we create different node group for different teams. And for each node group, we can enable autoscaler. So if one team is very busy, their node group will grow. They will get more nodes. While another team, if they're not busy, their node group will stay stable. So in this way, you can get more nodes for some busy team while it doesn't impact other team. Yeah. Cool. So Okay, I took a lot of challenges. Probably it's a lot. So here is my experience after working in different companies to make Spark easier for user. So we build Spark as a service. So this try to separate the underlying Spark physical environment from the end user. So you can dynamically tune your Spark environment without impact end user. That's why we call it the Spark as a service. So normally we have a user side command line tool, or it could be a core, or it could be a UI, whatever you can build it. So it's the tool, the end user will interact with Spark application. And in the server side, we have an API gateway. So people can just use their command to submit Spark to this gateway. And in this gateway underlying, it can have multiple Kubernetes cluster or multiple Kubernetes namespaces. The gateway can dynamically route the user Spark application to different cluster or namespaces. So you can control this routing part. Yeah, it's very, so you can get a very high availability for your system. For example, if your Spark class, Kubernetes cluster is down, or you want to restart or upgrade, you can temporarily disable the traffic to that cluster and route the user traffic to another cluster. So you can do some operational work, but users still can use your system. They don't see any impact. And also you can add remove resource very dynamically. Cool, yeah, again, I want to check there's some comments, any question, yeah.
One question, how about using Airflow for scheduling? How do you feel about that?
Great. Oh. Yeah, so Airflow work naturally with this scenario because we have an API gateway. So it's very easy to add an Airflow operator. You just write some HTTP request in Airflow. Then you send the request to the API gateway. It's a REST service. Then in Airflow, you can schedule your job very easily. We did that in different companies, yeah. And it works very well. Yeah. I know there are some existing Airflow operator, some using DB, some using some other stuff. Most of this not work very well. You have to figure that out, yeah. Cool, so. Okay, this is a very, very quick summary. To run Spark on Kubernetes, the major benefit is you get very low operation cost. And but you have a lot of work to get started. So a lot of things to figure out, a lot of things to learn in the very beginning. Then I'm trying to think how to make things easier for all these Spark users. This is what I come out from my mind. So feel free to update or to discuss this part. First, you need to automate the Spark environment. For example, you have different classes, you have different namespace, you want to add and remove nodes. This will happen very often in your production environment. You want to make this automated. And you want to make this repeatable, because these days, sometimes people may have multiple cloud accounts, like you have multiple AWS accounts, you have multiple teams, they may want to have different accounts. Sometimes they will want to use different Kubernetes cluster. You need to maintain and deploy things for different teams multiple times. So make things repeatable is very important. And another thing is zero time to market. So these days, things are moving very fast. So it's tough if people spend too much time just get their first Spark application to run. It's tough for some companies. So try to lower the barrier for people to get their application running. With these thoughts, I start to build an open source project, try to address this issue. I call it DataPunch. It's a tool right now. It's an automated tool to deploy Spark on Kubernetes. This is a very quick example. With this tool, it's a command line. With just one click, it will automate all these things for you. For example, it will go to AWS and create a EKS, set up IAM role, and create service account, install Spark operator, and Autoscale, all these things. Just with one click, it will do all this for you. Also, it will create an API gateway in the cluster. So right away, you get a running REST server. So you can use a curl command to send an HTTP request, or you can use a command line tool to submit an application. So things are dramatically simplified. So with one tool, you get all this repeatedly, and in a very short time, maybe just a few minutes to get your Spark application running. So Spark user don't need to learn all kind of Kubernetes internal knowledge. Yeah.
That seems handy.
Okay. Yeah, it's very handy. Very good word. Yeah, very handy. So I'm doing this right now as mostly a hobby. So if people are interested, feel free to work on this project together. Yeah. This is how I designed the DataPunch architecture, the tool. Yeah. So the tool has a command called punch. So it takes the input for punch is topology. So each topology define where your service environment. It could be Spark, or it could be maybe Hive or something like that, or maybe some other environment. So the command tool will take this topology and translate that to some deployment. So it know, okay, what component to add, what component to change. Is a deployment. It's like something like an execution plan. And in this deployment, in this plan, there are multiple steps. Then the punch command just run step one by one, and different steps doing different things. You talk to AWS or you talk to Kubernetes to add stuff there. Here are some examples of different topologies. So you can have a simple EKS topology. It will just create an EKS cluster for you. It can have Spark on EKS. So this doing all this Spark stuff. It can have Hive, metadata, this kind of thing. Yeah. Yeah, why doing this DataPunch project? Some benefits people can get from this project is you can dramatically lower your learning curve. So previously, if you learn Spark, learn Kubernetes, get it work, it takes several days. So with the DataPunch tool, it takes just minutes. You can get stuff work. And you can deploy your stuff again in several minutes, not hours. If you do it manually, it takes you multiple hours. It dramatically reduces the time windows to get things work. And it also changes the operation from some manual deployment to automated and repeatable deployment. So it just helps your life a little easy. Cool. Yeah, I think that's most of it. I will take away after I check the chat windows. Any question? Oh, demo. Oh, good question. Yeah. So good. Okay, let me see whether I can demo it, but I will try. Okay, would the DataPunch work with Terraform? Good question. In theory, it will work with Terraform, but I haven't get time to implement it yet. So in my design, I keep this in mind. Each punch command take this deployment and different steps. Right now, I use Go language to implement each step to do things. But we implement this in a plugin model. So you can plug in your implementation. So you can have some implementation which call Terraform to deploy different pieces. It is supported in the design, but because I haven't get time on that yet. Also, I'm not super familiar with the Terraform. So
another way to do it, Daniel, would be to use Terraform to deploy an autoscaling group with a launch configuration. And in the launch configuration, you can run arbitrary code where you could call the DataPunch command. It's one way to do it.
Yes, yeah, that's another way to do it. So you have Terraform in the front end, and then Terraform can call this DataPunch. Yes, you're right. Cool. Good call out. So any other question?
Someone is asking, aside from the demo, which we all want to see, someone is asking, so DataPunch is a Spark deployment tool?
Yes and no. I start DataPunch with Spark deployment tool in the very beginning. Then I'm thinking it can be expanded to deploy other stuff. It can deploy high metadata. I also deploy Kafka. I also use it to deploy a Spark ingestion job. So it is pluggable and extensible. Yeah. Oh, another it could be used to deploy Hive. Okay, yeah. So let me quickly show the website. Maybe if people are interested in this project, so it's open source, so everyone go there. GitHub, DataPunch. Yeah, it's here. Maybe easier to. So here's some example. It can deploy all these things with a single script. In this script, you can chain different things together. For example, you can install a EKS, then get output to another thing called Kafka Bridge. It's a REST Kafka proxy. Then you can send output to Hive method store. It will deploy Hive method store. Then you can send output to Spark on EKS. So it can chain all these pieces together and deploy something in this diagram. So in this diagram is a typical data ingestion pipeline or environment. So user send data to Kafka REST proxy, REST API, then it go to Kafka. Then you have some streaming application to read from Kafka and write to S3 and register your table in Hive method store. It can deploy all these things. But because I don't have too much time working on all this stuff, so I spend most of the time to make it work very well with Spark. For other pieces, it is working right now, but they still need more work to do there. So if people are interested, so we can work on this together, yeah. Oh, GitHub URL, yeah, GitHub URL is simple. Just datapunch.org/punch, yeah. So here, datapunch.org/punch, cool. And okay. On separate note, AWS SAM. Yes, there are many ways people try to work similar issues, to be honest. So Punch is my way to try to get things easier. There are many other ways, and I'm not, so far it's kind of people very creative. It's just many options. So you can try a different one. So hopefully in the future, it can converge. But right now, there are many options. Like Sam is, I know some startups are doing some other very interesting work, trying to make things easier. It just, I think the problem is common. To get Spark or some complicated thing work in Kubernetes, it needs a lot of work. People all feel the pain points. So they try to come up different ways to solve these problems. It just, it's still in very active area. It's not converged to a single solution yet.
If we could see a demo, that would be awesome.
Oh, yeah. So let me, just a second, let me double check. Okay, so. Okay, I think, let me try. Okay, so let me do this. So I have some quick start. You can run with the MiniCube or you can run with EKS. Both are working. Let's start with MiniCube. I normally run with EKS, so but EKS may need some time. Let's start with MiniCube first. Oh, I already have the project. I built it, so I have a punch command. So you can just do this. Punch install Spark on EKS with this thing. Oh, I need to add another thing. So go to this quick start. So if you want to have some password, you can specify a password. And if you want to print out some example, this will be more convenient. So let me try to run this. So again, the punch command install a topology with some arguments. So okay, that's right. You see, it's a oh yeah, that's some MiniCube. MiniCube keep changing their Kubernetes version. That's the problem. So you see, they probably update to this new version. So we can try EKS now. So the user guide is here. No, sorry, not this one. We can see the user guide. Okay, user guide, it has some MiniCube, it has punch on AWS. I already have AWS configured, so I won't configure it again. So I can just copy this command. It's very similar, just install this topology. And this topology is generated and it will try to resolve some names. And it's running right now. The first step is try to create an EKS cluster. You see, it's creating the cluster right now. AWS, it will take several minutes to give you the EKS cluster, so we need to wait for a while.
While we're waiting, there's one question. Is the Hive server in your diagram using Hadoop MapReduce or using Spark operator workers to run compute?
Hive metadata server. Is the question about how metadata server or about how to run Spark?
The question is about the Hive server.
Oh, Hive server.
In one of your topologies, you mentioned that you could create the Hive server. Yeah.
I just take the open source Apache Hive metadata server. It's not a Hive server. It's different. It's just metadata part. It's not Hive. Then I run Spark and register a table in this Hive metadata server. It doesn't use a Hive.
Chiwei, hopefully that answers your question.
Hopefully, yeah. But let me know if there are other questions. So Spark is very flexible. It can interact with Hive server, but without Hive server, it can just use Hive metadata store to store table metadata. So both are works. And actually now there are more and more people running Spark with Hive metadata server, but without Hive server. So they're different. So cool.
Sorry, I took you away from your demo. I'm sure we want to see how
anyway, we need to wait there. So it's good chat. Let's go back to the demo. Okay. It's still. Oh, it's print out. Sometimes EKS take 10 minutes. It depends on AWS. So another feature I can show you. Well, you can click this anytime. It's very idempotent. You can write again. It will try to create. If it's already created, it won't create again. It just will check status and waiting. You see, it's check status and waiting again. It's very idempotent. So let me try to explain some details here. It generates a topology like this. It's a template. You can fill in some values by this template. And it will resolve this template to some concrete values, this or transform topology. Yeah. This is how it resolves. In the end, that template, the value inside the template will be populated with some real values and generate a final topology. This topology, it has something like a VPC, S3, EKS cluster, control plane role, security group, a bunch of stuff. It will try to generate a default one, try to make it work. But if you have different value, for example, if you want to use another security group, you can change this and change the rule, a bunch of things, yeah. And it can add node groups. You can specify different instance type and how many nodes you want to have in the node group. It will set up NGS ingress, so you can access the gateway using HTTP. It can try to set up Autoscale, yeah, on this. Then it install Spark stuff like operator, gateway. Oh, it's install history server as well. But by default, it's disabled. But it do. it does install history server, makes things a little convenient. So I add this part very recently. Yeah.
Oh, did you use a library to build these final templates?
You mean this one? This template?
Yeah, the question is, what library did you use to build these templates?
Oh, it build me transform this template with these variables to the final template, to the final topology. If mean this transformation, I just use the Go standard template library. The Go programming language, it has a templating library coming just with Go. Yeah, I use that. Yeah, it's very convenient. Yeah, it's just embedded in Go language. Yeah. Okay, cool. So let me check. Oh, it's still okay. I probably should run this before the talk. So anyway, this is sometimes EKS just slow. And
do you run into any scaling issues? Is there a limitation on scaling or?
Yes, there are scaling issues in every place. For example, for Spark, if you run a lot of nodes in the Kubernetes, you will hit scaling issue. The Spark operator itself doesn't scale well. You need to tweak some part of it. So in my previous work, yeah, we dig into the source code and tweak some part of it to make it more scalable. And other part, like if you have a lot of load, you will trigger AWS rate limit. If you use AWS, yeah. For some part of it, the rate limit is pretty small, so you can hit that very easily. One example is your system may call API server in EKS, Kubernetes. There's an API server. Many operations in Kubernetes will call that API server. And that API server has a limit. For example, you can only send so many requests per second, or you can send only certain amount of requests at the same time. We hit that limit previously. So in the end, we have to work around. So one quick way to work around that is try to avoid use a huge Kubernetes cluster. You will hit these issues very easily if your Kubernetes cluster is huge. Well, how huge is huge? It's hard to say. So normally if you have several hundreds of nodes, it should be okay. If you have 1,000 nodes, most of the time it's okay, but it depends on your traffic pattern. If you have maybe 10,000 nodes, well, it's too big, it's too huge. It's definitely not good. So the sweet spot, I would say, several hundred nodes. If you keep in that level, the chance you hit the scalability issue is very low. So beyond that, you will hit a lot of scalability issues. Yeah.
Hey, so, hey, Bob, this is Chester. So
okay, hey, yeah.
So in your diagrams, you mentioned that you actually has two clusters. You can switch off through the gateway, right?
Oh yes.
Are you suggesting that in different jobs you're launching different clusters, or basically that's just these are just okay, the high availability?
Cool. Yeah. It depends on your goal. If you want to high availability, yes, this can provide high availability. I think we did this in my previous work. For same user, we can just randomly route to different cluster. We add a weight, and some cluster may have higher priority, so we can get high availability. But another scenario is we want to isolate different users or different teams. So sometimes there's a big team. They are very noisy. They tend to cause a lot of traffic to the cluster. Sometimes they may even bring down the cluster. And there are some teams, their traffic is very stable, but very critical. These are very different patterns. In this case, we just separate their traffic to different Kubernetes cluster so they don't impact each other.
I see.
Yeah.
But within one cluster, so you basically, you can launch multiple jobs as you wish, right?
Yes. We also use namespace in Kubernetes cluster. So again, we can route based on namespace inside the same cluster. And in each namespace, you can assign certain compute resource and you can run multiple applications there.
Got it.
The beautiful part is it's very flexible and dynamic, and you can configure your system as what you need. And everybody needs different. But if you design your system in this way as a service, you can deploy it in different ways to fit different needs without changing your code. So that's the beautiful part of this design.
Sure. I'm just kind of trying to imagine in my head, like compare this kind of a diagrams with a service like Databricks, for example. So like, for example, you have a Databricks and behind the scenes, they probably using Kubernetes as well. So we basically launch a Spark cluster with say 10, 20, 30 nodes and small jobs and running for a couple hours and then shut it down. And then we do that repeatedly for hundreds of jobs. But the cluster is small. I mean, in terms of a Spark cluster, it's small. But I think I just try to map in this world. Are we talking about one Kubernetes clusters in each Spark cluster, essentially a subset of a databases with a bunch of pods, or is each job is a one cluster? So it's kind of try to imagine how do we map them?
I see. For Kubernetes, yeah, we already see AWS may spend 10 minutes to create a new Kubernetes cluster. I would say it's not efficient to launch a new Kubernetes cluster for each new Spark job. It will take quite a few minutes. But to mitigate that, you can run a Spark cluster with 0 node, or maybe just with 1 node, then enable autoscaler on that. In that way, if a Spark application submitted to that cluster, Kubernetes will trigger autoscaler. That is much faster to add a new machine to the cluster. It may just take 1 minute or 2 to add a new nodes into the existing cluster.
Got it.
Yeah, so you still have do not have resource waste, and you can get a very fast response time. Oh, I'm going back to the command. Okay, it's created the EKS cluster and it add a new node group here. So again, I want to show you. Okay, you can kill this anytime. I kill it. Now just run again. It will remember previous things. Then you will see it will try to create EKS. Then find EKS already there. It just skip it. Then it will try to add a node group. Yeah, you see. It tries to add a node group. It's still creating. It just waits. So we can still wait here. And hopefully we can. I want to show in the end it will print out something. You can just copy paste and run your Spark. That is very convenient. So maybe just a few minutes. Yeah. I want to see question. Yeah. Any other question?
I think we're almost to the end of the hour, so maybe we have time for one more question.
Cool. So let's see, what's the question here? Ray. Also.
Oh, I was just clarifying an earlier question that Ray had.
Oh, I see. Cool.
I have a question if nobody else has one. But what do you want to do to make this open source project production ready, or is it ready to go for companies to deploy it, to use it to deploy in production?
Okay, yeah, I would say it is production ready for some small scale because everything is default. I take the default public open source Spark operator. It can run in some small scale, and the Punch tool can deploy a cluster for you. But if your scale grow big, the open source Spark operator, it has limitation. You need to modify some part of it. I did that in my previous company, but it's not open source yet. So you will need to do something by yourself.
Okay, you need to modify the Spark operator. Got it.
Yeah. Yes.
Great.
Cool. So okay. So the command is going to load the balancer right now. Yeah, it try to be smart. It create an ingress controller and it will check load balancer to make sure everything is good. So normally, if you do this by yourself, you have to do it manually to repeat checking status, doing stuff, and then check status again. It's a lot of manual work. Okay, very close. It's the operator.
I have a couple of questions, if you don't mind. I know time is running a bit close to 9 o'clock, right? So, but I have a couple of questions because this one is talking about Kubernetes KS. But you know, there's one production called OpenShift, which is the business version of the Kubernetes from the Red Hat.
Yes.
So what's the major difference between the Kubernetes KS cluster and I mean, Kubernetes is from Google, right? But is there another feature, basically, I mean, the OpenShift has, or KS doesn't have, or KS has it, but OpenShift doesn't have it?
I see, I see. In my understanding, OpenShift is an on-premise version of Kubernetes. It should be standard Kubernetes.
Okay.
But I never use OpenShift yet. I mostly use AWS EKS. Yeah.
Okay, I see. Yeah. So yeah. Okay. The other question is like this, because this topic is more.
Sorry to interrupt. We can stay on for more questions afterward, but I want to go ahead and thank our speaker so that if anybody needs to drop, it's the end of the hour. But Bo, if it's okay, we'll stay on and answer some more questions if that's okay. So
yeah, I'm totally fine. Yeah, cool. Yeah.
Great.
Okay,
thanks,
sure.
Thanks everybody. Feel free to drop.
So my next question is like this, because this one is more about develop the Spark as a service on the Kubernetes cluster. But say I have like you mentioned, I have the OpenShift, basically it's on-premise that cluster running the jobs, but I have the Spark cluster basically on the cloud. So how to trigger the Spark job on cloud from the OpenShift say command? Is there any way to do that? Say it's not like this, because this one is more like a deployment on the same cluster, right? So I have because Spark has a job as a service, but say I have a specific cluster, say Databricks, right, on the cloud, right? Like but I do have the OpenShift is on-premise, but I want to like a sort of orchestration and running the schedule jobs for that cluster. So how to basically from the OpenShift perspective to do that, to trigger the schedule job on that Spark. So it's pretty much like a separate class, but I want to kind of like incorporate them together, right? And then
I see.
Yeah.
For cloud, do you manage your cloud resource by yourself, or you mentioned the cloud is managed by someone else?
Well, the cloud infrastructure is managed by the cloud vendor, right? But on top of that, we have the sort of, let's say, Delta Lake or Data Lake, which means we can Autoscale, we can configure, we can set up those different classes. So yeah.
Got it.
But also we have the ADF, which is say Azure Data Factory to orchestrate. But the things, if we do have the like on-premises KS like OpenShift, how would I basically to orchestrate or trigger the job on that cluster? So that means like two separate clusters, but I want to using the Kubernetes as one of the like a overall job scheduler or controller, right? To control those clusters. Is there any way to do that?
Okay.
I mean, it's not the best way, I know that, but sometimes from the corporation perspective, they want to do that. You know, some big company, they have this kind of corporation, since they said, oh, we want to, we still have some legacy systems, right?
Yes.
On-premise, but some of the data on cloud. So we want to using one of the on-premise, say cluster, say Kubernetes OpenShift, so control everything, right? So it's not the best practice, I know that, but they still kind of have these kind of requirements to do that.
Okay. Yeah. I may not fully understand, but
yeah.
let me try to address
No,
it.
no worries, no worries. I'm
Yeah,
just curious because I want to get some idea. Like, yeah, no worries. I know it's a bit hard because even myself, I don't think that's the best way to design.
Please let both answer the question.
Yeah.
Yeah.
Normally, when people have this hybrid environment, people will create an abstraction layer, then use that abstraction layer to integrate different pieces, either cloud or your OpenShift on-premise. Try to hide the online detail from end user. In this way, you can reduce the migration cost. I mean, there's no migration, you support both. You can switch between both. Also, it's easy to manage resource in different sites. That's, in my experience, normally how people do this. So try to create some abstraction layer, yeah.
Abstraction layer, but that layer is
sorry to interrupt. I just want to mention we're over time, and I have to.
okay.
I really want to thank our wonderful partner AI Camp, who has provided this awesome Zoom so that we can be here and have the community conversation.
Yeah.
Feel free to post your questions on the meetup page, and we can follow up there. This has been a great talk, lots of discussion. This is super exciting, but I want to be cognizant of everybody's time constraints. Thank you, Bo. This has been fabulous, and we can follow up on the meetup page.
Sorry, just I want to demo.
Oh, yeah.
Yeah. So we finish run the command, it's print out some example. So you just copy this example, and then you can run your Spark. That's how easy you get your first Spark running in a few seconds, in a few minutes. Yeah.
Nice.
Yeah. So you can check the website to try this yourself. Yeah.
Very cool, Paul.
Yeah, that's it. Thank you, everyone. It's very great discussion, and thank you, our host. And yeah.
Thanks, Bo.